In this video, we're still going to be working with three-dimensional shapes. So we did the outside of three-dimensional shapes previously, so that's surface area, and it was square units. So what we're going to do in this video is we're going to start talking about the volume of prisms and cylinders. So volume is going to be the inside of the three-dimensional shapes. So I want to make sure, all right, this one, remember, I know that you would know, it's a T-box, okay? It's mostly rectangle, so it's a prism. As a matter of fact, it's all rectangle, so it's a rectangular prism. Now, do you remember in Math 210 when we had those base 10 blocks? Remember those little bitty cubes that were your ones? Volume would be how many of those cubes it would take to fill up this box. So if I open the top of the box up and filled it full of those cubes, the volume would be the number of cubes it would take to fill up the box. So that's why with volume, it's going to be cubic units. So it's the measure of the inside of a three-dimensional shape. That's what volume is. So this video is going to do prisms and cylinders because it's the same formula. And then the next video that you watch is going to be volume of cones and pyramids because, again, those formulas are the same. So let's go get the PowerPoint and we will get started. Hopefully that surface area worked out great and volume will be just as easy. Now, I do want to reiterate this idea about the units. So you learned to convert like inches to feet, and then last time like square inches to square feet, and now we'd have like cubic inches to cubic feet. Okay, so let's go look at just a few just to make sure that you're okay with it. I think you'd be fine, but it makes me feel better. So let me get something to write with because first of all, I need to correct something that I saw a minute ago. I want this one to be cubic inches, and I want this to be cubic feet when we get down to it. Okay. All right. So we're going to do it exactly the same way. Big to small, you multiply. Small to big, you divide. And remember, you're not always going left to right. You're going from number to blank. So up here, my number is here and my blank is there. So that's why I'm going from cubic centimeter to cubic millimeter. Now remember, centimeters are bigger than millimeters. All right. I'm stepping down. So I'm going down to the right. Okay. So when you're going big to small, you multiply, so that's why there's a times. There are 10 millimeters in a centimeter. They're one step apart. See, 1 0. Now, remember what you're really doing. You're saying 2 35/100ths times 10 to the third power. What do you do in order of operations? Do you do exponents first or do you do multiplication? That's right, you do exponents first. So I've got to say 10 cubed and get 1,000. 10 times 10 is 100. And then 100 times another 10 is 1,000. So 10 times 10 times 10, 10 to the third is 1,000. And when you take your calculator or by hand and you say 2 35/100ths times 1,000, you get 2,350. But remember, when you multiply by 1,000, it's going to move the decimal 3 places to the right. So 1, 2, add a 0 and go 3. Now again here, I'm going from number to blank, so I'm not going inches to feet, I'm going from cubic feet to cubic inches. Now isn't a foot bigger than an inch? So again, I'm going big to small, so I multiply. How many inches are in a foot? 12, but you already knew that. But because this is cubed and this is cubed, I've got to cube that conversion factor. And if you multiply 12 times 12 times 12, you're going to get 1,728. So I've got 1 1/3 times 1,728. I've got a fractional problem. So remember, I need two fractions. I changed the mixed number to 4/3. We learned how to do that already. Single integers go over 1. Then you multiply straight across the top, numerator times numerator. I got 6,912. And then across the bottom, I got 3. And then when I divided these, I got 2,304. So there's my answer. Now here I'm going number to blank, all right, so I'm going cubic decameter over to cubic kilometer, okay? So remember on your stair steps, decameters are smaller than kilometers. I'm going up the steps. So when I'm going small to big, remember I have to divide. And from decameter to hectometer and then hectometer to kilometer, so I've gone 2 stairs. So they're 2 apart, so 100. And then 100 to the third power is 1,000,000. So if you take 176,000 and divide by 1,000,000, you get 176 thousandths. Okay? So I don't think that's going to cause you any trouble. It's just if the units are squared, you have to square the conversion factor. Okay? If the If the units are cubed, then you're going to have to cube it. Let's clear those drawings so that doesn't bother us when we go to kind of to our next slide. Okay, so let's kind of remind you some things about units and then get started. Now you're going to have linear units, square units, and cubic units on your test. So I do need you to make sure that your answers have numbers and units. If you leave the units off, I'm going to count them. Okay. So if it's just regular linear units like feet to inches or cups to pints or tons to pounds, then you just have linear units. So that's used when you're doing length or perimeter, circumference, or arc length. Those just have what you think of as regular units. If you're doing area or surface area, you have to have square units, square inches, square meters. And like we talked about today, if you're doing volume, you have to have cubic units. So make sure that you have the right units. All right, let's go do some prisms first. So how do I know this is a prism? Because it's mostly rectangles. Okay, so that tells me its last name, prism. Now remember, if you have any shape that's not a rectangle, that would be its first name. We'll do one of those in a second. But this time they're all rectangles. So remember, it's like my tea box. All right, this is a rectangular prism. Now, I want to make sure we're clear about something. The formula is capital B times H. I need you to put capital B. All right, don't put little b or you'll get confused. Capital B stands for the area of the base. Now look what your base is. Remember this first word, that's your base. So this is a rectangular prism. So I'm going to find the area of that rectangle using my area formulas and then say times the height of the prism. So it's like I'm doing this, I'm calling this bottom down here my base. That's a rectangle. Well, how do you find the area of a rectangle? Don't you do length times width? So my base is a rectangle, so the area of that rectangle, length times width. So look at this bottom. Now I do this length times this length. Now before I panic, I know that's 22. How did I know, where did I get the 12? Well, these are rectangles, so if this is 12, what's this length right here? Isn't it 12? If it's easier for you to see, if that one's 12, that one's 12. So 12 times 22 gives me the area of the rectangle down here on the bottom. So the area of this rectangle down here on the bottom, all right, that area right there is 264 square centimeters. So do you understand? I'm going to put that in place of my B, the area of my base. So that B gets replaced with 264 square units because it's an area, and area is always square units. Now this H is the height of the prism. How tall, how high is that prism? Do you see it's 28 centimeters? So when I said 264 times 28, I got 7,392. And then of course, square centimeters times another centimeter does give me cubic centimeters. So in volume, I do always get cubic units, okay? So let me kind of go get rid of this drawing, clear that drawing so it doesn't bother you on the next one. Okay, and let's go do one that's not a rectangular prism. That's a different kind of prism. Now, this is one you've seen before when you were doing surface area. See, most of the sides are rectangles, so that's how I know it's a prism. Well, how do I know what kind of prism? Is there any shape on this that's not a rectangle? Do you see I've got a trapezoid? So that's how I know it's a trapezoidal prism. And its first name is its base, okay? So my base must be a trapezoid. So my capital B, remember your formula down here, is capital B times H. That's your formula for the volume of a prism. So over to the side or before I start or wherever, I go get the angle, I go get capital B. So since B is a trapezoid, this is your formula for the area of a trapezoid, 1/2 the sum of the bases times the height. Now remember, the bases of the trapezoid are the parallel sides. Now on your test, I'll mark it, but that side is parallel to that side. So those are my bases. So this one's 15, so that's why I put 15 there. Now, I don't know how long that side is until I remember, oh wait, this is a rectangle, so if that's 5, the side right across from it's also 5. So that's how I knew that I've got a 15 and a 5 for my bases. And I add them, and 15 plus 5, of course, is going to be 20. Now remember, the height is the height of the whole trapezoid. Okay, I mean of the trapezoid, not of the prism. And the height, remember, is the height of the trapezoid, so it's from one base to the other base. So how far apart is it from 15 to 5? Do you see that it's 7? So that's why that height is 7. So order of operations, parentheses come first, so I added and got 20. Then half of 20 is 10, and 10 times 7 is 70. So the area of that trapezoid right there on the top is 70 square meters. So that 70 goes in place of that B. Now this H right here is the height of the prism. So it's a little confusing, so that's why I put them in different colors. That might be helpful to you on a test. This H in this form is the height of the trapezoid, and the H in this form is the height of the whole prism. So that's from trapezoid on the bottom to trapezoid on the top. How far apart are these trapezoids? Aren't they 6 meters apart? So that's why that height is 6 meters. And then 70 times 6 is 420. And then, of course, I end up with cubic because it's volume. So let me clear that notation, and then we'll go work another one just to make sure. I'm sure you're fine, but it makes me feel better. Okay. All right, let's do another one. Let's do maybe a triangular prism. Okay. Now, how did I know it was a triangular prism? Well, I knew it was a prism because I've got 1 on the bottom, 2 on the other side, 3 rectangles. And I've got 1, 2 triangles, 1 on the front and 1 on the back. So remember majority rules. If it's mostly rectangles, it's a prism. So that's how I knew to write prism. Then if there's any shape that's not a rectangle, that's its first name. So it's a triangular prism. So remember, this first word is going to be your B. All right. So my base is a triangle, so I need the area of that triangle. Now remember, base doesn't mean bottom. So the triangles are my base. So here's this triangle in the front. That's my base. So I need 1/2 the base of that triangle times the height of that triangle. Remember, I'm looking for right angles. So the base of the triangle is 10 millimeters. The height of the triangle is 12 millimeters. So 10 times 12 is 120, and half of that is 60. Or you could say half of 10 is 5, and then that answer 5 times 12 is 60. Remember order of operations. All right, but remember, community property of multiplication says when you're just multiplying, that's all you got. It doesn't matter what order you do it. So the area of that triangle on the bottom is 60. So this B down here is going to get replaced with this 60 square millimeters. Now this H in this form is the height of the whole prism. That's from base to base. So your base is a triangle. So how far apart are the triangle on the front and the triangle on the back? Do you see that they're 14 millimeters apart? So that's why 14 is my height. Height doesn't always mean up and down. Height is the distance between your bases. And so when I multiplied that out, I got 840 cubic millimeters. Okay, so your formula when you've got a prism is always capital B times H. And capital B is the area of your base. And that H is the distance between those bases. Okay, so let's go get a cylinder. Now, before I start a cylinder, I want you to look at something. Here's a can, okay, can of tomatoes. Do you see that the bottom is a circle? Well, what if I traced this circle and I cut out like 100 of them and started stacking them? Do you see that I'd eventually get this can? So all that really matters is how big is the circle and then how many do I stack? So do you see it's still going to be capital B times H. It's just your base is going to be a circle, okay? And with prisms, bases can be different things. So that's why your formula, instead of writing, you can write capital B times H for a cylinder, but because your base is a circle, they just went ahead and stuck in the area formula for a circle. So a lot of times when you're looking in a book, for a cylinder, they'll have pi r squared h, the area of the circle times the height of the cylinder. All right, so let's go look at one. All right, there's my volume formula, but do you understand that right here, that part right there, that pi r squared is really the same thing as capital B. Okay, so I've got to have the radius. So look at your picture. That radius is 3 inches. So that 3 inches would go there, but I've got to square it. Now, how high is that cylinder? So from circle to circle is 9 inches. So the height is 9. Order of operations, parentheses are first, but I don't have anything inside of a parenthesis to multiply. So next I look for exponents. So I've got to do 3 squared, which is 9. And then 9 times 9 is 81, so I get 81 pi, and I get cubic units because it's volume. Now, we talked about this before, but just reiterate, you can either leave me this for your answer, or you can go to a decimal approximation by substituting in an approximate value for pi. But if you do a decimal approximation, change from equal to square equal. So I wouldn't care on a test whether you put 81 pi cubic inches or whether you said approximately 254 and 3400 cubic inches. Your choice. Let's try one more just to be clear. This time they didn't give me the radius, they gave me the diameter. But my formula is still pi r squared h for the volume of a cylinder, but I need the radius. Well, if it's 10 inches all the way across, then halfway is going to be 5. So that's how I knew the radius was 5 inches. Remember, you do exponents before you multiply, so 5 squared is my 25. Then 25 times 6 is 150, but don't forget your pi. So it's exactly 150 pi cubic inches. And if you'd rather go to a decimal approximation, and with elementary students, that's probably what you're going to want to do with your students, because it makes more sense to them. Because 150 pi is more than triple 150. So they do better when they see it. So all I did was just round it. So my volume is about 471 cubic inches. So that's it. When you're doing cylinders or prisms, your formula for volume is always capital B times H. On a prism, that B can be different shapes. If it's a trapezoid, find the area of the trapezoid. If it's a triangle, find the area of a triangle. If it's a cylinder, though, that base is going to be a circle. So that's why it's pi r squared, the area of the base, and anytime it's the height. So try those homework problems. If you have any trouble, then make sure that you let me know. So email me, we'll set up a meeting, we'll get together. So next video that you watch will be finishing up volume.